All right, good morning, everyone. We will go ahead and get started. So today's the first day of the unit, and we will be talking about rational expressions. Today we are just going to do what's called simplifying, but we will also spend a day multiplying, dividing, adding, and subtracting. So what is a rational expression? They're just expressions that have algebra in them, like x plus 2, x minus 3, and the numerator and denominator are both polynomials. So here's some examples. If I had 2 over x plus 5. So this is an expression. 2 is a polynomial. X plus 5 is a polynomial. Another example would be something like x squared minus 2x plus 7 over x cubed. That is a rational expression. The thing to remember about rational expressions is that you cannot divide by 0. There is no way to divide by 0 and get a number, because anything times 0 is 0. So denominators of a fraction cannot be 0. So because denominators can't be 0, we get what's called excluded values. So for here, x cannot be -5 because -5 plus 5 is 0. Here, x can't be 0 because 0 to the third is 0, and you can't divide by 0. So as we're working with these, we need to list the excluded values. And they're values of a variable that result in a 0. Result in a denominator of 0. I said that wrong. And must be excluded from the domain of the variable. Here are some examples. What number would make this 0? Well, when b is -7, -7 plus 7, 0, you can't divide by 0. So I would say b cannot equal -7. Here, what number minus 4 is 0? That'd be 4. So I'd say a cannot equal 4. Here, 3 times what minus 1 is 0? This may be harder to think of. So I might say, okay, when is this 0? Well, I'd add 1 to both sides. Divide by 3. And I get x is a third. Now, we're not really trying to find a value of x. We would say x cannot equal a third. So 3 times a third is 1. 1 minus 1 is 0. You can't divide by 0. Here, there's probably 2 numbers that make this 0 because it's a quadratic. So remember, we learned, and you're going to have to learn, or not learn, but remember how to factor. So what multiplies to -12 and adds to -1? Remember, we do that process when there's 3 terms and the first number is a 1. So what multiplies to -12 adds to -1, that's -4 and 3. So you'd get x minus 4, x plus 3. That means that x cannot equal 4, x cannot equal -3. If I plug 4 in here, I get 4 squared 16. 16 minus 4 is 12. 12 minus 12 is 0. You can't divide by 0. If I plug -3 in here, -3 squared is 9. 9 minus -3 would be 12. 12 minus 12 is 0. You can't divide by 0. So the first step is to know how to put down the excluded values. And looking back This should not say X. Glad I caught that. This should say A. This should not say X. That should say A. My variable up here was an A, not an X. So that means this should also be an A. Okay. All right, so let's get to it. Here's an example. These examples are a little different. You should have done something like this in Algebra 1. Notice there's no plus or minus signs. So when we do this problem here in a second, it's different. So because there's no plus or minus sign, 7 is separate from A, is separate from B. 21 is separate from A, is separate from B. None of them are combined together through addition or subtraction. So how do I simplify this? Well, I write down the problem. And then I recognize, and this is their way of doing it. I'm going to show a different way. So what I would do is I'd say, okay, that's -7. And then A squared means A times A. B to the third means B. 21, I'm going to write 21 as 7 times 3. Partly because then the 7s cancel. A to the 5th is A to the A, and then a B. So now I could see what's in common and eliminate common factors. So I could eliminate the 7s. I could eliminate an A and another A and then one B. So what's left over, I crossed off the 7. I did not cross off the negative. I crossed off the A, I crossed off the A, I crossed off the B, A or B. I have a B and a B left over, that's -B squared. I crossed off the 7. I did not cross off the 3. I crossed off A, I crossed off A. I did not cross off A, that's A cubed. And notice we got the same result. Their way is just different. Now I need to also put down excluded values. If A is 0, then this whole thing becomes 0. If B is 0, then this whole thing becomes 0. So I would say A cannot equal 0. B cannot equal 0. And this would be my simplified expression. All right, here's another one. So if we were in person, I would say, hey, why don't you try this example yourself, and then we would check it together. If you're watching this later, I encourage you to hit pause and try it yourself and then see what the answer is. 35. So 35 is 7 times 5. And then I have an X and then 2 Y's. 14 is 7 times 2, 2 Y's, and a Z. So this time, and I'm going to use a highlighter, I think it's easier to show, the 7s cancel. What else? What else? Looks like a Y cancels. It's a 1 for a 1. Okay, and this Y cancels. So what's left over? 5X over 2Z. What are the excluded values? If Y is 0, this whole thing's 0. If Z is 0, this whole thing's 0. So I would say Y can't be 0. Z can't be 0. And that would be my final answer. Another way to do this is 35 over 14 are both divisible by 7. 35 divided by 7 is 5. 14 divided by 7 is 2. I have X, no other X's, so of course that's going to stay an X. I have y squared and y squared, those cancel, and then I have a z left over. So you can also subtract exponents. Like on this one, I could have done 5 minus 2, and that's 3. I could have done 3 minus 1, which is 2. So you could also do it that way also. All right, I want you to notice that this one's different. Here's the common mistake I see kids do. X squared, cross them off. You cannot cross off x squared because x squared goes with the 2x and the 2x goes with the 15. These are all together. So you cannot cross off x squared. Here, you could cross off y squared because they're not together. Okay, there is no union, there is no addition or subtraction. But here you cannot do that. So what do? Well, you factor. So the first one, I need to find, this is a is 1, 1, 2, 3 terms. I need to find two numbers that multiply to negative 15, but add to negative 2. What multiplies to negative 15 and adds to negative 2 is negative 5 and 3. So my numerator becomes x minus 5, x plus 3. So instead of having one expression that's all together, now I have two separate. That's what happened. I went from 1 to 2. The next one. What multiplies to negative 12, but adds to negative 1. Multiplies to negative 12, but adds to negative 1 would be negative 4 and 3. So I get x minus 4, x plus 3. I then look for anything to cancel out. So I have an x minus 5 here, no other x minus 5s here. X plus 3 and x plus 3, those go away. So I'm left with x minus 5 over x minus 4. Now, what are my excluded values? If x is 4, this becomes 0, and 0 times anything is 0. So x cannot be 4. What makes this 0 is when x is negative 3. Negative 3 plus 3 is 0. 0 times anything is 0. So x cannot equal negative 3. This is my final answer. So all I did was what it's called simplify. So it's not really an answer, it's just a simpler form. We found common factors, we cross them off. There is not always a common factor. Sometimes this is as simple as it goes. All right, again, 3x minus 15, they're together. So we need to find a way to separate these. Before you start thinking, oh, make an x, there's only 2 terms. You cannot make the x when there's only 2 terms. So when I look at this, I notice that 3x and 15 have a GCF of 3. So I'm going to factor out a 3. 3 from 3x is just x. 3 from 15 is 5. Because 3 times x is 3x, 3 times negative 5, negative 15. In the denominator, I have 1, 2, 3 terms. So what multiplies to 10, but adds to negative 7? That would be negative 5 and negative 2. So I put x minus 5, x minus 2. And then I look for common factors to eliminate. I could eliminate the x minus 5s. and I get 3 over x minus 2. Now, what are the excluded values? You look only at the denominator, not the numerator. X cannot be 5. X cannot be 2. So I say x cannot be 5. X cannot be 2. And then that would be my simplified expression. All right, another example. X squared minus 9. So there's not 3 terms. I can't do the x. X squared and 9 do not have a GCF. So then what do you do? Well, you may remember that x squared is a square. It's x and x. 9 is a square, 3 and 3. So I can write this as x plus 3. X minus 3. And I know it's been a while since we've done that, but remember, I have x squared minus 9. I would make this into a square, x and x. Make that into a square, 3 and 3. And then you do x plus 3, x minus 3. One's plus and one's negative to get rid of the middle term. All right, this one. What multiplies, because it's 3 terms, a is 1. What multiplies to negative 27 and adds to 6? Oh, why is it so blurry? There we go. So what multiplies to negative 27 and adds to 6? 9 and negative 3. Then I get x plus 9, x minus 3. Eliminate common factors. And I get x plus 3 over x plus 9. What are the excluded values? X cannot be negative 9. X cannot be 3. So what I want to do now is I want to show you what this graph looks like. So if I was to graph this in Desmos, you would have some asymptotes. And so I'm going to show you what this looks like. And we're going to specifically look at negative 9 and at 3. So here's Desmos. I have x squared and on bottom, oh, that was x squared minus 9. Down here, I have x squared plus 6x minus 27. And I want to show you what's going on here. So if I type in x equals negative 9, I have what's called a vertical asymptote. Okay. Now, we'll talk about this later, but you have asymptotes, and then you have holes. And it looks like at x equals 3, we have a hole. And the reason why x at 3 is a hole is because we also had x plus 3 or x minus 3 numerator denominator. And so we'll talk about that later. But I just wanted you to see visually that you should have an asymptote. And so this is what a rational function looks like. We will be having asymptotes. Just wanted to make sure you were aware of what those look like. All right, so now let's go back and look at the practice. So here's the practice. Simplify each rational expression. State any restrictions on the variables. So simplify, simplify. These are GCF problems, the first two. GCF, GCF. This is a perfect square, x squared minus 16. Number 5, looks like a GCF problem. GCF, A is 1. A is 1. Difference of two squares. A is 1, A is 1. This one, there's no pluses or minus signs, so I don't have to worry about factoring. I can just eliminate stuff. This is the one I first did where you can write out all the factors. Here's a GCF, A is 1. Here, A is not 1. It's been a while since we've done one like that. Here, A is not 1. Okay. So it might be good review to do one where A is not 1, and then we'll call it good. So I'll do number 12. Number 12, how do I factor this? It's been a while. When A is not 1, you take 3 times negative 4. That's negative 12. Bring down the 4. You ask yourself what multiplies to negative 12 and adds to 4. That's 6 and negative 2. You then put x plus 6. You then put x minus 2. And then this is the only thing that's different, is you take this number and you divide both of these by that number. If it reduces, you reduce. If it doesn't reduce, you slide it to the front. 6 divided by 3 reduces. That's 2. 2/3 does not reduce. The 3 slides to the front, and you get 3x minus 2. So all I found so far is that the denominator factors into x plus 2, 3x minus 2. So this factors into this. Now x squared minus 2x minus 8, that's easy. A is 1. What multiplies to negative 8 and adds to negative 2? That'd be negative 4 and 2. Negative 4 times 2 is negative 8. Negative 4 plus 2 is negative 2. So I get x minus 4, x plus 2. And then the only thing that goes away is the x plus 2's. So I get x minus 4 over 3x minus 2. What are the excluded values? X cannot be negative 2. X cannot be, ooh, I'd have to solve that. I think it's 2/3. If I set 3x minus 2 equal to 0, add 2 to both sides, divide by 3, I get 2/3. And then number 15, how can you tell whether a rational expression is in simplest form? It's like, how do I know if this is in simplest form? Well, I know this is in simplest form because x minus 4, do to it, 3x minus 2, there's nothing else I could do to it. There's no GCF, there's no way to factor. So this is in simplest form. All right. Other than that, that is all I have. Hope you have a good day, and I'll see you next time. Bye-bye.